Now you're registered with SAS On Demand and enrolled in this course. It's time to start learning to write a program. Log into SAS Studio if you're not already logged on. Once you log in, you'll see the SAS dashboard. Click on SAS Studio. This is your main screen. On the right-hand side of this screen is a new empty program window, which looks like this. In SAS, the program window works much like a word processor. There are a few basic steps that SAS and all other statistical software languages require when you begin writing a program. First, you will call in or point to the data set that you will be working with. You'll use the Libname statement to do this. Libname is short for library name. You can copy the statement from the text below this video and paste it into the SAS program window. This is the first line of your program. It's the same for everyone, and you'll never need to change this line in your program throughout the rest of this course. The Libname statement simply tells SAS where to find the data. It's important because it will allow you to successfully access your dataset. The name MyData within the statement is a label chosen as the name that the dataset will be given when it's stored within the SAS library. Next, the path name, enclosed in quotation marks, provides the location in the SAS cloud where the data is being stored. Finally, you'll include access equals read only so that the raw data cannot be modified. A very important feature of SAS syntax is that every SAS statement ends with a semicolon. Without a semicolon, sometimes called a command terminator, a SAS command is incomplete, and this will cause errors when you run your program. Notice that SAS uses color coding to help you write and debug your program. Remember, you don't want to see red in any of the code you write. You do, however, want to see blue, purple, and sometimes green. Blue font indicates a SAS keyword. Keywords are a primary part of SAS programming language. They're part of the established SAS lexicon. Most SAS statements begin with the keyword, just as all SAS statements end with a semicolon. Purple font indicates that SAS considers this section of your statement part of a string. A string in SAS consists of consecutive alphanumeric or other characters enclosed by single or double quotation marks. Green font indicates that these are your statements, the code writer statements. They're kind of like notes to yourself about part of your program. They're usually enclosed within asterisks and forward slashes, and they're not analyzed by SAS. If you write a line of code and absolutely none of it appears in one of these colors, you only have black font on a white background, then you want to take a closer look and see what needs to be corrected. SAS is generally not case sensitive, so whether you write your programs in lower or uppercase letters or a combination of both, SAS will be able to read it successfully. Following the libname statement, the SAS program requires a data step. The data step reads in your specific data set and prepares it for use. The word data indicates to SAS the beginning of a data step in which a temporary data set is created. Here, the data set is assigned by the word new followed by a semicolon. Next, the set statement is used to tell SAS which data file to set for analysis. MyData is the label created in the libname statement above, and it's followed by a period. Nisark_PDS is the actual name of the Nisark data file located on the SAS cloud server. To end the data step, there are different options. Here we'll end with a Proc statement. A Proc statement is a procedure statement which indicates to SAS you want to perform some manipulation of the data. This is a Proc sort statement. It's asking SAS to sort the data according to one or more variables. A good habit to get into is to sort the data according to the variable that uniquely identifies each observation, that is, the unique identifier. In the NESARC dataset, the unique identifier is called ID num. So this line of code is telling SAS to sort the data in the NESARC dataset by ID num. Remember to always end a command with a semicolon. At this point in the program, you should write this line of SAS code using the name of the variable that uniquely identifies the observations in your dataset. These can typically be found in the codebook. Now that you've ended the data step with a sort statement, all procedures that follow will be written to request specific output or results. Now's the time to save the program you've started. To do this, click the Save As button above your main program window. This button is located just to the right of the Save button. The default name is Program, but you should feel free to rename the program as you like. The frequency procedure is typed as proc freq, and it's followed by a semicolon. Next, include the table statement, typed as tables, followed by a list of variables that you would like to examine.
For my research question, I'm interested in looking at the association between how much a person smokes, that is, quantity and frequency of smoking, and the presence or absence of nicotine dependence. Going back to the NESARC codebook, you may recall that I have a number of variables that measure smoking behavior and nicotine dependence. It's the actual name of the variable, rather than the longer descriptive name, that I'll include in my program in order to generate frequency distributions. I have the names of each of the variables circled here in red.
Here's an example of a NESARC program with the frequency procedure and table statement added. Then a run statement is added at the end of the program. The run statement is responsible for executing all the previously entered SAS statements in this program. When you add a proc freq and table statement with your own variables of interest from the dataset you've chosen to ask your research questions about, and then conclude with a run statement, you've written an entire SAS program. You will build on this program as you progress through your project. Before you run the program, it's always a good idea to save it. Click the Save button at the top of the program window. After you save the program, you can run it by clicking on the Run button at the top of your program menu. SAS Studio has 3 different tabs located at the top of the main program window. You write your code on the page marked by the Code tab. Just to the right of the Code tab is the Log tab, and to the right of that is the Results tab. Once your program is finished running, either the Results tab or the Log tab will open. It's a very good habit to get into to check your Log tab first after running a program, so you can check for any errors in your program. When you click on the Log tab, you'll see a section at the top of the page entitled Errors, Warnings, Notes. If any errors were detected in the program, the number of errors, located in parentheses, will be listed to the right of the red X errors icon. The same with any warnings or notes. If there are any warnings, the number will be listed in parentheses to the right of the yellow triangle warnings icon, and any notes SAS has about your program will be numbered, again in parentheses, to the right of the blue I circle notes icon. If you double-click on any of these icons that indicate the number of errors, warnings, or notes that exist in the program, then a list will appear beneath the double-clicked icon. If you do find any errors listed on the log page, go back to the code page, correct the errors, save the corrected code, and then run your program again. If no errors are listed on the log page, click back to the results page and you'll see the results of your program. In this case, it will be the distribution tables you generated. In this example, our program is run successfully.
If I look at the first table, which shows the distribution of responses for the variable tobacco dependence in the past 12 months, I know from consulting my codebook that 1 means yes and 0 means no. Following this list of response options, the table also shows the frequency of each, the percent of individuals with and without nicotine dependence, the cumulative frequency, and the cumulative percent. By consulting your codebook, you can interpret and describe each of these frequency tables in the same way.